Assalamu alaikum students. I am your computer teacher Aisha Anwar. We have been studying about system development life cycle or software development life cycle. In previous lecture we have studied about few phases of SDLC. Today we are going to revise them and we will study few more phases of SDLC. So dear students, these are the phases of SDLC, which include defining problem, planning, feasibility study, analysis, requirement engineering, design, coding, testing or verification, deployment or implementation, and in the end maintenance and support. In previous lecture we have studied about from problem solving to analysis and including requirement engineering with further its 3 steps and designing further with its 2 steps. We have discussed these. Today we are going to revise till designing and we will study further coding, testing and verification. So here is the diagram which we have discussed in previous lectures also. It is a diagram of SDLC in which all the phases are clearly mentioned. As you can see that all the phases are in some flow which is definitely followed by the previous one. For example, defining, then we will coming towards the planning. After planning we will come to the feasibility, then analysis, and like this. It is very much important to follow these phases in the sequence. We cannot perform coding before analysis. We cannot do this, and in the same way we cannot deploy anything before coding. So it means all of these phases come in the proper sequence. First of all we have to do planning. After planning we will perform feasibility study, then analysis, requirement engineering, and so on. So in defining phase we have discussed that we will be defining the complete problem that is to be addressed. In planning phase, the objective of the project is defined, estimation of resources is planned, and all the information which is provided, that is analyzed in the planning phase. After planning we comes to the feasibility study. In feasibility study we assess the strengths and weaknesses of the proposed system, that what are the positive points and what are the weaknesses of that system. And during feasibility study we conduct the analysis of the proposed solution on these bases: technically, economically, operationally, legally, and schedule wise. We should given all of these things according to the exact requirements. Then after feasibility we perform analysis phase. During the analysis phase the project team determines the end user requirements. Often this is done with the assistance of client focus groups, which provide an explanation of their needs and what their expectations are. It means during analysis phase their needs and their expectations are defined at this stage, and various questions are asked during the analysis phase. After analysis phase requirement engineering comes. In requirement engineering there are 3 steps that are performed: requirement gathering, then requirement validation, and in the end requirement management. In requirement gathering all the requirements are gathered with the various set of activities, by filling out the questionnaires, by asking by conducting some sort of meetings and interviews. We gather the information, and there are so many activities to gather the requirements. So there are 2 type of requirements that are to be defined in this phase, that are functional requirements and non-functional requirements. Functional requirements are those requirements which specify the functionality of the software. In short, it defines the function or the purpose of the software, that what our software is intended to do. And in non-functional requirements, we specify the criteria for the judgment of the functional requirements, or you can say we specify or we mention the criteria for the judgment of the operation of the system or the proposed solution. It describes that how well the system performs its duties. These two type of requirements are gathered in requirement gathering phase. Once these requirements are gathered, we move towards the requirements validation. Requirement validation is concerned with examining the requirements to certify that they meet the intentions of the stakeholder. It means all the requirements mentioned by the stakeholders are meeting the requirements or not. In requirement validation, the requirements elicited are reviewed to check the requirements are complete and accurate. In this phase, it is also checked that all the requirements that the user want have been elicited. Elicited means have been mentioned or highlighted. After gathering and validation, requirements have to be managed so that all the requirements can be integrated into the system. Requirement management is performed to ensure that the software continues to meet the expectations of the users. Requirement management needs to gather new requirements if they feel like some requirements are missing from the previous stages. After requirement management, the process of requirement gathering is completed. Once all the requirements are completed, we will move towards the design phase. This design phase is basically the architectural phase of the system design. In this phase, the system is designed with the help of different type of charts, and we have to make its logical design. And in this phase, mock-up screen layouts are also developed by the users. Mock-up screen layout means the fake screen layouts. We can say that in design phase, we build or we basically plan the structure of the software. In design phase, there are two types of activities that are mandatory to perform. These are algorithm writing and flowcharting. First of all, we will discuss what are algorithms. An algorithm is a basically step-by-step procedure to carry out the solution, or you can say that it is simply the solution of a problem that is written into some English language with using some keywords also. Like in the given example, you can say that the system is getting the marks from the user. After getting the marks from the user, it is checking the condition. If marks are greater than 40, then pass, print pass, else print fail. All the algorithms start with the keyword start and finish with the keyword end, and in between start and end we write the basic program, but in some English language with the help of some symbols also. After writing algorithms, we convert those algorithms into the diagrams, and those diagrams are known as the flowchart. So we can say that a flowchart is a type of diagram that represents an algorithm or a process. In flowchart, we show the steps of algorithm with the help of boxes and some particular shapes, and we also define their order by arrowheads and connecting the boxes. This diagrammatic representation of algorithm gives a step-by-step solution or step-by-step understanding of the problem, and it also tells about the flow of the control of the problem. In flowchart, we can easily analyze and design the system. And in the end of the software development, when we are documenting or we will perform maintenance, these flowcharts may be required. So it is very much important to document these algorithms and these flowcharts. These are the few shapes that are used in flowcharting. To represent start and end, we use oval symbol. We represent input and output operation with the help of a parallelogram. The processing is indicated with the help of a rectangle shape. The flow of a system is defined with these arrowheads. If some decision or condition is to be checked or some decision is to be made, we use diamond shape, and these small circles are used as connectors. They are used to join the flowcharts. So here is the flowchart of the previous algorithm. First of all, we are representing start with an oval shape. Then we are getting marks from the user, so it means these marks are the input to the system. Here in the diamond shape, we are checking for the condition and we are making a decision if marks are greater than or equal to 40. If yes, then it will simply print pass. Here parallelogram is used because printing on the screen will be the output of a program. So we have used parallelogram. If marks are not greater than 40, if this condition is false, then simply print fail, and after printing the message it will be ending. So you can see that start and ending is showed with the oval shape. Once the system design is completed, we will move towards the construction or coding. In this phase, the developers actually write the code or the program to the solution. During the construction phase, developer basically executes the plan. The developers design the databases, generate the code, and process the data flow, and they design the actual user interface screens. Those interface screens that were previously developed during the design phase, and we call them mock-up screens. In construction or coding phase, those actual screens are designed. During this phase, data is prepared and processed as many times as necessary to refine the code. Here in this stage, the code is written and refined many times. So the process of writing this computer code is also known as computer programming, and that code is written with the help of programming languages. And those languages can be C, C++, Java, PHP, or any other programming language. At the end of the construction or coding phase, the complete program has been developed. For example, we are discussing the student's examination system. So we have written its algorithm and we have made its flowchart. Here is the code for that example. Those students who are familiar with C language, they will find it easy, as C++ has minor differences with the C language. But students who are studying programming language for the very first time, they have to understand it very carefully. You can see that here is a line written as #include iostream.h, then #include conio.h. These are the header files. We can say them as the header files. These header files have their own purpose, and we will be studying these header files and the programming from the chapter number 3 and onwards. Then you can see that the word main is written. It is the function. And what is the main function? We will also study from chapter number 3 onwards. You can see that here the line written as Cout enter percentage of the student. This line will display this message on the screen. The user will enter the percentage and that percentage is stored in a variable named as the percentage. Next, here it is checking the percentage. If percentage is greater than or equal to 40.0, then Cout pass, else Cout fail. The word Cout is used to print the message on the screen. Simply a message either pass or fail will be written on the screen depending upon the percentage that is entered by the user. So it is the very simple example of a program. After coding, the testing and verification stage comes. During the testing phase, all aspects of the system are checked functionality wise and performance wise. During the execution of a program, we have to find out the errors. To find out the errors or bugs is called the testing. Errors or bugs, they are the alternative words which are used for you can say the mistakes that are in the program. So the bugs or the errors are identified in the different modules. So the purpose of testing is to evaluate and determine whether the system is meeting the requirements and it is giving us the required results or not. So testing or verification of the software is actually operating the software under some controlled conditions. It is the process of checking the items for consistency by evaluating the results against pre-specified requirements. For example, we are discussing the example of a percentage of a student, whether the student is passed or failed. So we will enter some random values into the program and we will check accordingly whether the system is producing the right results or not. So for this particular example, we will write 2 test cases to check whether it is giving the correct pass message or correct failed message. First of all, we will run the program. When the program will ask to enter the percentage of a student, we will enter 70 and it has printed on the screen the message pass. It means for one condition it is okay, and for the other condition we also have to check it. So when we run this program for the second time and we will enter some marks that are less than 40, let's say 20. If we have entered 20, it should print on the screen the message fail. If it is working like this, so it means our code is perfectly okay and it is working according to the requirement. If we enter the marks greater than 60, for example, greater than 40, for example, I have entered 70 and it is printing fail instead of pass. It means there is some error in the code. So the developer has to recheck and verify the code for the said cases. Okay students,